Okay, it has been a bit surreal seeing Log4J in the news. It's on news headlines. Even Time magazine has an article, "What is Log4J?" It's crazy. Even when the Equifax hack happened, the news mainly covered the data breach, and Struts wasn't so much in the headlines. But this classic Java library hitting mainstream, it feels so odd. It's like tomorrow if Miley Cyrus tweets, "Oh boy, I'm having so much fun deploying my Kubernetes clusters." What? These two worlds are not supposed to meet. Anyway, in this video, I will explain to you what exactly this Log4j vulnerability is and why it happened. But also share something a little more important. You see, these vulnerabilities come and go, right? This will likely get patched. People will move on. Life will likely go on. But this has actually got me thinking a little bit about open source in general, and I'm beginning to look at open source libraries a little bit differently. So let me explain. You probably already know what Log4j is. It's a very popular Java logging library that you can use for logging stuff from your code. So you can log things to a file, like when something goes wrong, error messages, debug messages, and then you can look up log files later and troubleshoot, right? Typical stuff. Although, to be honest, logging libraries in Java have always been a little bit of a mess. I have a video explaining what the different logging libraries are, and you can check them out over here. So even though it's a bit of a mess overall, Log4j, which is one of these logging library options, has been doing its job pretty well for many, many years now. But there was a dark secret which was hidden under the surface, a major security vulnerability that's now come into the open, and we have a big issue on our hands. Any Java application that uses Log4j can be hacked. That is anything lower than the recently patched version of Log4j, which is 2.16, right? So this has actually resulted in enterprises racing to patch their Log4j versions and deploy the newest version. And it's also resulted in hackers racing to exploit targets before said enterprises do a patch. So much fun. Now you might look at your app and go, well, hey, I don't use Log4j, so I'm good. But wait, not so fast, sir or madam. Log4j is such a popular library that even if you aren't using it directly, you might be depending on another library which actually uses Log4j for logging. Or that might depend on another library which uses Log4j. At this point, considering how popular Log4j is, there is a good chance that any decently sized Java application running out there probably has Log4j installed in it. There's a developer security company called Snike, or however we pronounce it, but that found that about 60+% of Java applications that they scanned actually uses Log4j indirectly and not depending on it directly, right? So this is a widespread problem. And now not only is this problem widespread, but the severity is pretty high too. There is something called the CVSS score, which stands for Common Vulnerability Scoring System. And this CVSS score has actually rated 10 for this vulnerability. It's 10 out of 10, the highest it can possibly be. Now, why is that? The reason for this is that this vulnerability enables what's referred to as RCE. Okay, it stands for Remote Code Execution. What this means is this actually allows hackers to be able to run any code on your machine by hacking into your application which uses Log4j. All right. They can run any code they want. I'll be explaining the actual vulnerability in a little bit, but I hope you understand why this is so serious. This is the reason this vulnerability is actually nicknamed Log4Shell. Okay, it's almost like anyone can open a shell on any server and issue commands. Yeah, it's that bad. Okay, so this is big, but what exactly is the problem itself? There are actually multiple things that have happened and all together resulted in this vulnerability. I'm going to start with item number 1. Log4j allows you to log expressions. Okay, this should be obvious. And let's take a look at this line of code. What you're doing here is you're getting the logger, which is this line, and then you're logging an error, okay, using the logger.error. And what you're doing here is plugging in the error message from the error object into the string. So Java is going to run this piece of code that you have over here. It's going to get the error message, and then it's going to send this value. Then Log4j is going to plug that thing into this string. You're going to get an output which contains error message, colon, and then whatever is error.getMessage is going to get plugged into these curly braces, and Log4j is going to print it. Simple, right? Now, as long as you're passing in expressions, as long as the value itself is being passed to Log4j, this is standard logging, right? There's nothing special about this. This should make a lot of obvious sense, okay? This itself is not a problem. Now, I'm going to introduce the second item in this trifecta that just caused this problem, which is JNDI, okay? JNDI stands for Java Naming and Directory Interface. JNDI allows you to store Java objects in a remote location and then serialize them, kind of like streaming them to your JVM. As scary as this might seem, this is a technology that's been around for a while. This was pre-REST API popularity, and this was the way distributed Java systems would work with each other, right? This is how they would communicate. This has fallen out of popularity now, but it is still there in Java, all right? So, for example, this is an Active Directory link, okay? LDAP URL, I can invoke this URL, and I can get a serialized Java object from somewhere else. In this case, it would probably be my profile object that I'm going to get from Active Directory, okay? This has got nothing to do with Log4j at all, right? This is a Java feature that's been in the platform for years. You can disable it. You're encouraged to disable it, but it hasn't been removed from Java yet because Java never deprecates anything, and it strives for so much backward compatibility that even my great-grandmother's Java code can run with the latest JVM and the latest Java compiler. Anyway, it's there. Most people leave it on, and it's harmless in and as of itself. Okay, back to Log4j and feature number 3. Now, at some point of time, back in 2013, a contributor introduced a change to Log4j that allowed you to do these kind of JNDI lookups from the logging message. A good use case for this would be if you have some kind of a centralized log configuration from a config server, and you want to serialize that configuration using JNDI and have that affect log messages, like say the logging path or prefix messages with a certain value, etc. You've seen string interpolation with something like this. Now imagine something like this with JNDI lookup, okay? So what you're doing here is you're doing a prefix. You're getting a prefix for the logging message from JNDI by passing the JNDI URL as an argument. You're not just passing a value that this thing resolves, you're actually passing a string value, but this is not something that Java resolves. This is something you're passing to Log4j. Basically, the difference is Log4j does lookups for certain types of strings. For example, if you have any old string like hello world over here, what it does is it basically inserts the string in the curlies. So you would see insert string here, colon, space, hello world in the log. However, if the string that you're passing as an argument has this special syntax, which is the $curly, then this is a clue for Log4j to actually look it up. In this particular case, the actual string within the $curly is JNDI colon. So it says, okay, this is a JNDI lookup. It's going to look up the value, and it's going to insert that in the double curlies for the template string. Another example, environment variables. Here, $curly is wrapping an env colon. In this case, it realizes, hey, this is an environment variable lookup. It is going to look this up and insert the value in the double curlies. And this is it. This is the vulnerability. Wonder how this is a vulnerability? Let me give you an example. Let's say you have a search page, okay? Your user can enter some search criteria and then submit it to the app. Your app takes it and searches it. Whatever it might be, doesn't matter. Whatever your app is doing, all right? In your app, you're taking the search criteria and you're logging it. Let's say you're doing something like this, okay? You're getting the logger, and then you're saying search page, search issued for the search term, and then this is the text input that the user entered. Now, what's the problem here? Now, imagine I put a search term like this, right? I'm searching for this term. What happens? What will this code do? Well, what this code will do is basically make a JNDI request to whatever domain I pass in the JNDI, all right? So I'm basically passing in a JNDI URL as a search criteria. So when this goes out and logger is logging this thing, it's going to be like, hey, this is a JNDI URL, so let me actually resolve it. So it's actually going to make a JNDI call to whatever URL I pass. Now you see the problem, right? Here's a simple diagram that explains this. Here's your vulnerable app. You pass in request, which contains a JNDI URL, and you set up a JNDI server over here. We have malicious code over here, and a JNDI endpoint returns your malicious Java class. It can be any Java class. So you pass this thing in, your application takes the string and like, okay, you might not get any search results, but what the application does is it tries and logs it. Log4j is going to look at that URL and it's going to make a JNDI request to your malicious server, and you return back a serialized malicious object. What you put in that object, who knows? It's going to take this, and now you have an object in this JVM, which this application really didn't put in there. You put in there. You have the ability to put a Java object into somebody else's JVM. That sounds crazy, but that's exactly what this vulnerability is. So in your Java object, you put a static block which contains whatever code you want, and this is going to run it. Imagine being able to instantiate a Java object of your code in the JVM of like a popular e-commerce website or JVM of a popular social media website. You will have control over everything. And you can do this as many times as you want. Execute whatever code you want in that object. All right. This is what's referred to as remote code execution, RCE. Does this remind you of anything? This should remind you of something else which has a similar vulnerability. It's called SQL injection. Okay, we've seen a similar pattern before. You can pass in something in your query parameter, which ends a SQL statement and starts a new SQL statement. And now if your application is taking your input and say, select star from user where username equals and your input, you can basically end the SQL statement that it's executing and then create your own SQL statement, which deletes everything, which, your application is going to run it. So you don't really do string appends, you don't do resolves when you're passing in user input, right? You don't evaluate user input. You have to plug in values which you have control over, right? So this is kind of similar to that. You can kind of call it log injection. And to be honest, log injection has been happening for a while. Okay, you can technically do log injection if you have badly written code and it's not even related to this vulnerability, right? So for example, take a look at this, right? So let's say I put a search term like this, ending the previous line with this /n, and I'm kind of mocking a new log line, okay? It's almost like the application is logging it, but basically I'm passing this. I'm passing this as a search term. I'm ending the previous line, and then I'm starting a new log line. So when this gets printed in the log, if somebody were to take this and print this directly in the log, what does it look like? It looks like there is a new log line which says, user has purchased this product for $1 million. And then /n, there is another log line saying error running this transaction for this particular user. So somebody can look at those two log statements and go, hey, this person tried to purchase it and it didn't work. So maybe we have to refund this person $1 million. I would happily take that. So this is basically log injection. This is really, really old technique, and people handle it differently. They don't directly add the stuff. They handle /n's and all that. But in general, log injection is relatively harmless. There's not a lot of damage you can do. People are not going to look at the log message and say, hey, this person, you have to credit them $1 million. It's not going to happen, right? It's very easy to find out that this is log injection. But remote code execution is a much, much bigger problem. All right. Now, how do you mitigate this? How do you solve for this? The first thing you can do, the easiest way to solve this problem is to set a couple of flags to false. Okay. There are two flags here, which end with trust URL code base. It's basically telling Java, do you want to trust code base, which is coming from a URL, some code which is coming from a URL, which handles the JNDI and RMI and all that stuff. Okay. You can set these flags to false, and Java is going to be like, when it tries to do a resolution for a remote URL, it's going to be like, nope, I don't trust any code that's coming from an external URL. Java is going to block it. Your Log4j resolution is immediately stopped right there. A lot of people turn it off because this is scary stuff, but there are a lot of people who don't even know that this exists, and they have servers running with this thing turned on. And now if they have this Log4j version, which is vulnerable, they have a problem. The thing is though, even if you have turned this on, there is still a problem. There is still a vulnerability. And this is with respect to environment variables. If the runtime were to actually make a call, even if it doesn't trust what it returns, even if it doesn't deserialize the object that it returns, you might still have a problem, because if the call goes out, you might be able to do something like this. You can plug in your search term to be something like this, your JNDI LDAP URL, and then you plug in the environment variables. Most of these servers have environment variables which contain secrets. So if you have an application running on AWS, I will probably have the AWS access key and the secret key in an environment variable. So if you were to plug this in, guess what happens? The Java runtime is going to resolve this. This is the access key and this is the secret ID. It's going to resolve this URL and make a call. Even if it doesn't trust what it gets back, the call has been made, and now this data has been sent to whatever is the hacker's LDAP server. And now the hacker has access to your access key and secret key. As long as the request goes out, it is a problem. So how do you remediate it? What's the solution? Well, there are a few things you can do. First is to upgrade to the newest version of Log4J. Should be a simple solution, but it can be problematic if you have dependencies which depend on something else, which depends on Log4J. This is tricky. So an alternative, which some companies have taken, is to patch the class directly, right? They get the newest version of the class for the Log4j release, and they put it directly in the class path. So they know wherever there is this occurrence of this class, just patch this directly so they don't have to manually bump versions for any dependency. If you're depending on some library and that uses Log4j, well, do you wait for that library to fix the issue first before you publish your version? Well, that can take a while, or they may not even do it, right? So a simpler solution is to just patch it directly. If you're using Gradle, there's something called dependency constraints in Gradle. Okay, so you can write code like this, which basically says, hey, I want this particular version of the library. No matter what the dependency is, this has strictly to be above 2.16. No matter how you do this, it's very important, like you might have guessed, to solve this problem before a potential hacker can leverage it to hack into your application. Now, if you know what the issue is, I have some thoughts about this whole issue in general, and some thoughts about open source in general. So open source has traditionally been thought to be secure, right? By default, it's open source, so it's secure because of this reason. The code is out there for everyone to see, right? People use this reason often. It's like the code is out in the open. So if there is a security vulnerability, people will catch it and people will fix it. This has usually been an argument for open source. Now, let's look at this Log4j vulnerability, all right? This was introduced back in 2013. This was found, the vulnerability was discovered, identified in 2021, late 2021. I put discovered in double quotes because was there any time when this was exploited? Have some people known about this all along, and have they exploited? When was it first exploited? We don't know, all right? The thing is, these kind of security vulnerabilities have happened before, all right? This has happened with Heartbleed. This happened with the Struts vulnerability. All these software were open source, right? The code is out in the open. And this is not just Java. This happens with many platforms. So if you look at this many eyes argument, it's like this code has many eyes on it. So any vulnerabilities will be caught. You begin to see a problem with that argument, all right? Even though the code is out there in the open, it may not always be caught, okay? Because people have to look at the right code for things to be caught, okay? And there's a lot of open source code out there. And not just that, the right people need to be looking at it, right? So I'm not a security expert. I might not have looked at that code and found a vulnerability. Some smart people looked at it and they found out. So are smart people who know about security looking at the right code? I also want to talk about the update messaging, right? I see a lot of messaging going on about Log4j itself, right? So I see messages like, okay, the Log4j team is working to fix this issue, okay? The Log4j team has patched this thing. They've released a patch. And there is this thing about Log4j team as if it's like a company, some kind of an organization, Log4j, which is working on this. But oftentimes, as with Log4j, as with a lot of other open source projects, they're all unpaid volunteers. Okay, they're doing this in their spare time because they're passionate about a problem. They're trying to solve it, and they do what they can to help the community. The reality of this is that mistakes happen, right? They are human. They make mistakes. Security is also a very hard problem. Okay, not everybody has the skills required to make sure things are secure. Not everybody has the skills required to validate security problems, to look for security problems. So the question usually is about the money. These libraries are used a lot. Something like Log4j is used in thousands and thousands of applications. A lot of people are using these libraries and making money from it. A lot of companies are using these libraries and making money from it. Is there not a moral responsibility or an obligation for that company to put money back into open source? Right? We talk about the support model driving open source for a lot, right? You often see, and there are a lot of success stories for this. You have an open source project, some company takes it, funds it, and then builds their business model around it, saying, okay, you use the solution, and then we're going to support you. And that's how they make money. And that they take that money and put it back into the open source solution. A lot of success stories for this. But What if that model isn't feasible? For something like Log4j, can you build a company that supports Log4j and make money from it? Probably not. So in that case, again, do companies which make money from this library have a moral obligation? I tend to believe that most companies have good in them. I see a lot of companies spending a lot of money on social causes, for example. You might be skeptical and say, well, they just do it for PR, but they are doing it. And I'd like to believe that people do it with good intentions. So isn't open source and funding open source, funding security and, funding basically just the making of open source projects, isn't that also one of those moral responsibilities that companies need to take? I will leave you with this thought, but hopefully this video has explained to you what exactly the vulnerability is and why it happened. Check out this other video linked in the description as well, which explains all these different logging frameworks and why it's such a mess. Thank you for watching.